Hello, sixth graders. Today we are looking at prime factorization. Our learning targets today are I can identify numbers as prime and composite. I can use prime factorization to determine the factors of whole numbers. And I can express a whole number as a product of prime factors with exponents. So you should have the title and all three learning targets written down. Okay, just a review on prime and composite numbers. A prime number is a number that only has two factors, one in itself, and a composite number has more than two factors. And factors, as a reminder, are the numbers that multiply together to make a number. So we're looking at determining if these are prime or composite. To do that, we can list out the factors. So the numbers that multiply to make 17, well, 1 and 17. I don't think there's anything else, so since it's only two factors, that would be a prime number. 11 has factors 1 and 11 that multiply together. I don't think there's any others, so that would be prime. Only has two factors. 15, well, 1 and 15 multiply together, and 3 and 5. So those are all of the factors, the numbers that multiply together. Since it has more than two, that's a composite number. 12, the numbers that multiply together, the factors 1 and 12. 2 and 6, 3 and 4. Since it has more than two, that is a composite number. For 24, we've got 1 and 24, 2 and 12, 3 and 8. You could stop here. Like, we know there's already more than two, so we know it's got to be a composite number. We wouldn't necessarily have to list out all of them, but we're almost there. I think 4 and 6 would be the last one. So it has more than two. It's a composite number. And the last one, 1. The factors of 1, the numbers that multiply together to make 1, are 1 and 1. So its only factor is itself. In order to be prime, it has to have two factors. Since this one only has one, it is actually neither prime nor composite. So remember, 1 and 0, those are the weird ones that are neither prime or composite. Okay, so we've got some vocab here that we need to write down. Basically, you should write down this box here. Okay, so composite numbers can be written as a product of prime numbers, which is our vocab down here, product of primes. I'll go into a little bit more detail after here. The product is the prime factorization. Okay, so that's showing a number split up into prime numbers being multiplied together, so something like that. You can use a factor tree to find the prime factorization. These are factor trees. So they are just the ways that we show the number being split up to get down to our prime factors. Okay. Remember, factors, those are the numbers that multiply together to make up another number. So if you have that paragraph written down, and I guess this part under it here, then you will be good to go on vocab. Okay, so we are going to do the prime factorization of 24. So this is breaking the number 24 down into prime numbers that multiply together and make 24. So there's two methods. One of them is a factor tree. So I start with the number that I'm factorizing, 24, and I'm going to split it. I'm trying to think of two numbers that multiply together to make 24 besides 1 and 24. Okay, we need to pick prime numbers. 1 is not prime, so we cannot do 1 and 24. Well, 2 and 12, 3 and 8, 6 and 4, any of those would work. I'm going to do 3 and 8. Then I'm going to ask myself, is 3 a prime number? Yes, so I'm going to circle it. That means it's done and I don't split it up anymore. Then I do the same for 8. Is 8 a prime number? Nope, so that means I can split it some more. So now I need two numbers that multiply together to make 8 besides 1 and 8. Well, I know that would be 2 and 4. Is 2 a prime number? Yes, so I'm going to circle it. Is 4 a prime number? Nope. So I'm going to split it up again. For 4, the numbers that would multiply together would be 2 times 2. 2 is prime, so I circle it. I just circle it to let myself that I know it's done. Now I'm going to list those out, multiplying them together. So I've got, and I put them in order from least to greatest. So 2 times 2 times 2 times 3. Okay. Now that is what we call expanded form. We can also write it with exponents or an exponential form. So we are taking 2 and we are multiplying it 3 times over. So in exponential form, that would be 2 to the power of 3 times 3. So that's in exponential form. Okay, it's written with exponents. Expanded form, it's expanded, it's stretched out. The other method is to divide by prime numbers. So I put down the number 24. I'm going to write this a little differently here. I'm going to do like an upside down division bracket. Now I'm trying to think of a prime number that 24 can be divided by. Well, 2 is prime, and I know that goes into 24, so I'm going to write it off to the left. Now I'm going to divide. 24 divided by 2 is 12, so I'm going to write that down below. And then I'm going to try again. Can 12 be divided by something or by a prime number? Yes, it can be divided by 2. 12 divided by 2 is 6. I'm going to divide. 6 divided by 2 is 3. Or no, sorry. 2 goes here. 6 divided by 2 is 3. Now 3 is a prime number, so that's where I would stop. So then everything here, those are my prime factors. So 2 times 2 times 2 times 3, or again 2 to the third times 3. Notice 2 different ways, ends up the same. So here's our next example here. Find the prime factorization of 18. So this would be a great spot if you're feeling comfortable to pause. Try both methods. You'll pick which one works better for you. But it is important to know how to do both of them, especially because when we get to greatest common factor and least common multiple, this method will be super helpful. So, but practice both of them. Okay? So if you feel comfortable, pause, try it on your own, and then come back and watch. Otherwise, follow along here. So factor tree for 18. So we need to find numbers that multiply together to make 18. Well, I know 2 and 9 multiply to make 18, or 3 and 6. So either one would work. I'm going to do 2 and 9. 2 is a prime number, so I'm going to circle it. 9 is not, so I need to divide that. I know that 3 times 3 equals 9. 3 is a prime number, so that would be circled. So now we are done. There's no other numbers. Everything is completed. So to write this out, again, least to greatest, 2 times 3 times 3, that's expanded form. You could also write it in exponential form, which is 2 times 3 squared, because there's 2 3's here. Now the method with division, dividing by prime numbers. So we have to pick a prime number that 18 can be divided by. Well, I know that it could be divided by 3, which is a prime number. 18 divided by 3 is 6. Well, 6 can be divided by 3. 6 divided by 3 is 2. Okay. And then 2 is a prime number, so now we are done. So this here, those are our prime numbers. So 2 times 3 times 3, again, or 2 times 3 to the second power. Notice we're getting the same answer either way, just 2 different methods. Pick which one is more comfortable for you, but be able to do both of them. Okay, there are times that the question will be worded like this: product of primes. Well, product means multiplication, and primes means prime numbers, numbers that can only be divided by 1 in themselves. So what we're doing is we're breaking this down into prime numbers that are multiplied together which is what we do when we find the prime factorization. So this is just another wording for prime factorization. So if a question asks you product of primes, please do not get thrown off by that. Okay. So 285, we got to find a number that 285 can be divided by. Well, it ends in a 5, so I know automatically it can be divided by 5. I don't know how many times, so I'm going to do some really quick division here off to the side. 5 goes into 28 5 times, which is 25. 3, bring down my 5, 7, so it goes in there 57 times. Well, 5 is prime. So now I got to figure out if 57 can be divided. I know that if I add the values of 5 and 7 together and they become they're 12, 5 plus 7 is 12. 12 can be divided by 3, so I know that this number can actually be divided by 3. 57 divided by 3 is 19. 3 is prime, and now 19 I know is prime. So writing this in order as product of primes, I'm going to write it from least to greatest. 3 times 5 times 19. Product of primes. Prime numbers being multiplied together. Next one, 160. Well, it ends in a 0, so I know it's divisible by 10. And I know then that means it's 16 and 10. Neither of those are prime, so I'm going to split both of them. 10 can be split 2 times 5. Both of those are prime numbers. 16 I could split with 2 and 8 or 4 and 4. I'm going to do 2 and 8. 2 is prime. 8 can be split with 2 and 4. 2 is prime. 4 can be split by 2 and 2. Okay. Notice that I favor factor trees, so that's the one that I'll be using. But if you preferred the division method, that's great. We would still end up with the same answer. So writing this out, we've got 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5, and then you got to remember the 5. You could also write this in exponential form as 2 to the power of 5 times 5. Just always read the question and see how it's asking you to write it. You can always go back and check to make sure that you did this correctly by going and solving and multiplying your answer back together. So I could multiply this, and I should then get 160 back. Okay, next we have prime factoring an algebraic expression. So algebraic means letters. Okay, so we have letters on here now. So we have 18 CD. So that means 18 times C times D. So what I'm going to do, I'm going to ignore the letters for now, and I'm just going to factor my 18. For this one, just for some practice, I'm going to do the division method. So I know 18 can be divided by 2. 18 divided by 2 is 9. And then I know that 9 can be divided by 3. 9 divided by 3 is 3. 3 is prime, so now it's done. So we have 2 times 3 times 3. Notice I'm using the dot now because since we're talking algebraic, we've got letters. If I write the X for the multiplication symbol, it might be confusing. And now all I do is I add on the letters. 2 times 3 times C times D. You could write it in exponential form, 2 times 3 squared times C times D. Again, just pay close attention. Usually you would have it written out like this in expanded form. Okay. Next one, 50 x squared y squared. So I'm going to factor the 50. I'm going to do my factor tree for this one. 50 I know can be 2 and 25, 2 being prime. 25 can be split with 5 and 5, 5 being prime. So now 2 times 5 times 5, and it has x squared. That means x is being multiplied twice. So I'm going to now write that out in expanded form, times x, and then I have to include the y, times y, times y. So that would be my prime factorization with that algebraic expression. Most often you'll write it in expanded form like that. Okay, so now we have find the missing prime factor. So they gave us part of the factor tree, or the prime factorization here. We know there's a 2 squared and we know there's a 3. We are trying to figure out what would fill in that spot, and when all of those numbers multiply together, it needs to equal 1,500. So there's a few ways that you could do this. You could make the entire factor tree for 1,500. That might be a little bit, might be a bit much. So what I'm going to do instead is I'm going to figure out what I have so far with that 2 squared and the 3. So I'm going to go 2 squared times 3. Remember, 2 squared means we are going 2 times 2, which is 4, times 3. Well, 4 times 3 is 12. So I know so far we have 12. So I got to figure out how much is left. And since we're multiplying, I'm going to do the opposite. The opposite of multiplication is division. So I'm going to take 1,500 and I'm going to divide that by 12. Well, 12 goes into 15 one time, which is 12. Subtract. Bring down my next number. 12 goes into 30 twice. 2 times 12 is 24. Subtract. Bring down my next number. 12 goes into 65 times. 5 times 12 is 60. So that means there's 125 left. So now I need to make a factor tree for 125. That's a little bit more doable than 1,500. So I know that 25 can go into 125, and if I count by 25s, 25, 50, 75, 100, 125, that's 5. 5 being a prime number. Well, 5 times 5 is 25. So, since there's only one spot, I know there's one number that has to go there, which is 5 to the 3rd power. If I were to multiply all of this back together, I should then get 1,500. And like I said, you could have started with 1,500 to start and do your factor tree to figure out what's missing, but that's kind of a lot. So I figured out what I had so far, divided it off of there, so then I was only looking at that empty spot. Okay, so if we try that again with this next one, 1,200, so far we have 1 times 2 to the 4th. So let's figure out what we have so far. So 2 to the 4th means we are taking 2 and we are multiplying it 4 times. Okay, so 2 times 2 is 4, and 4 times 4 is 16. And then we have 16 times 3. 3 times 6 is 18. Regroup the 1. 3 times 1 plus 1 is 4. So we have 48 so far between these two numbers. So I'm going to divide that off of there. I'm going to take 1,200 and I'm going to divide it by 48. 48 can't go into 1. It can't go into 12. I think 3 is going to be too many. Let me just double check. 8 times 3 is 24. That would be 14. Yeah, that's too many. So it goes in there twice. 48 and 48, I believe, is 96. I'm just going to double check. 16, 8, 9. Yep. So that's 96. Now I subtract. Okay, so this becomes a 1. This becomes 10. 10 minus 6 is 4. 11 minus 9 is 2. Bring down the 0. Let's see here. So 48 goes into 240. I'm going to guess 5 times. 5 times 8 is 40. 24. Yep. So 5 times, which is exactly 240. So I know there's 25 left. So now I'm going to make my factor tree for 25. That would be 5 times 5. And again, it makes sense because I only have one spot, so I need one number to fill in there. which would be 5 to the power of 2. Okay, so figuring out what I have so far, and then figuring out how much I have left that I need. Okay, so again, you're going to have these problems that you are going to try on your own. I'm not going to go through them, but I am going to be looking for these in your notes when I check them. So the first question, using a factor tree, find the product of primes of 34. Remember, product of primes is the same thing as prime factorization. You could do, instead of a factor tree, the division method if you prefer that one. Then you're going to do the prime factorization of 52 times g times h squared. And then you're going to find the missing number there. We have 2 squared times something equals 100, and you need to find a prime factor, so the number that you have has to be prime to fill into that box. And it might have exponents, it might not. But I'm going to be looking for these 3 questions at the end of your notes. That's all I have on prime factorization. Look back over your notes, check to make sure that they are good quality so that you earn full points. Check your understanding. Is this something that you could explain to somebody else? If not, you might want to go back and re-watch some parts of the video or try some more practice problems. And we are actually, I'll be checking your notes on Class Kick.